Happy St. Patrick's Day. Today I'll be working more on my advanced quantitative stock market model I'm working on in Python. I'm pretty close to the paper trading phase. I have a couple of really good models done, and today I'll be working on adding one last feature to see if this improves the model. And regardless of that, I'll then be automating the picking part of the model, and then I'm going to paper trade the models for a month and see how they do. And if they perform well over the month, if they're beating the S&P 500 by a significant margin, I'm going to go live with real money. So just to be clear, this is not financial advice. This is for entertainment purposes only and to show you how to code a stock market tool. So before I get into that, I'm going to go over real quick what I've done so far, what my goals are, where I'm at, and what I'm going to do moving forward. So these are the goals. First goal is to beat the S&P 500 by a significant margin in all regimes. So this shouldn't work just in a bear regime or a bull regime. It should work no matter what, and it should beat the S&P. It shouldn't match the S&P. Shouldn't beat it by just a little bit. It should be significantly better than the S&P 500. My second goal is so I'm coding all of this in Python. So not only do I want to do this for myself, I want to make a general Python tool that anyone can use to create models, test them, run through them without having to without having to code it from scratch. So this is something that I've found isn't widely available. So I want to make this widely available to everyone. Eventually, I'll be integrating this into a desktop app or a website, or possibly both. Speaking of this goal, the goal of getting a tool that anyone can use, um, here's the GitHub for the tool. It helps me out a lot if you star the GitHub, watch the GitHub, and follow me on GitHub. That helps raise my coding profile, helps me get coding jobs and freelance gigs. Also, if you're interested in this, you should subscribe because I work on this every day. Um, so, also join the Discord. The links for all that stuff's in the description as well. And so this is the outline for the model. So I have some stock data, price data, open, high, low, close, and volume for every day going back to 2011. Now you don't want to train your model on all stocks that have existed since 2011 because lots of them are crap, either penny stocks or really low volume stocks, and these are going to mess up your model. So the first step is isolating a universe of stocks, looking for good stocks, high volume stocks, without having look-ahead bias. Next step is training the model. I want to train the model. Right now I'm using a light gradient boosting method. I could be changing that in the future, but that's what I've been using for the last several months. Once I have a really good returns model going, I'm evaluating that on several metrics. And so once I'm really happy with the returns model, I'm going to feed that into a portfolio model, and the portfolio model is going to decide how to allocate money based on the returns model. So this is the first iteration of the model that I finished. I started this project at the beginning of the year. These are really my results from January. So I started out getting data from the NASDAQ database. It turns out this is inefficient and it's not easy to automate because you need to download a CSV for each stock each day. So I found a much better data source. The link for this is also in the description. It's a SQL database that I can get locally on my machine. In a few lines of code, you can install it on your machine. And with a couple lines of code, you could update it every single day. I had to do some steps to clean up the data. The main thing was accounting for stock splits, so the database wasn't accounting for this. So I had to go back and clean the data for each stock and say if a stock split's happening, account for the price change accordingly. Next, I did and the stock split's important because if you see here this teal line, that's the raw data that I had. And so Tesla didn't go through a huge drop right here. It just had a stock split. And so that's if I left the data in without accounting for the splits, it would learn the wrong things. And it would probably just stay away from any stock that's big enough and successful enough to be splitting. So once I had that done, the next step was to look at a basic analysis. And this is just the block plot is just looking at fundamentals. seeing how the different fundamentals are changing for a sector over time. At the right here, I was looking at comparing different stocks in a sector, in this case, the pharmaceutical sector. And so this is useful. You can see what things are overperforming, what things are underperforming. These are kind of cool to look at, but it's a qualitative analysis, and you can't really automate anything based on that. So I knew I needed something more advanced. And so, like I said, I decided to use a light gradient boosting method. These are really good for stock data. They handle a lot of data really well. And they also handle missing values really well, which is common in stock data. And they're really good at generalizing. They're really diverse models, so you can kind of feed it in any type of feature you want and not worry about the model breaking. And they handle time series data really well. So for all of these reasons, I've decided to use a light gradient boosting method. And so this is the best result I got from training the model. It was performing about 51.5% directionally accurate. And so that means picking up or down days. This is for single days. And so I tried to implement a portfolio strategy based on this model. I did find something that appeared to be successful. And so I'm looking if I'm picking from the outputs of the model, the lowest 500 by volume and weighting them accordingly. I'm underperforming the S&P 500. If I'm picking the 100 lowest by volume, I'm basically matching the performance of the S&P 500. If I do the 20 lowest by volume, I'm beating the S&P 500 now. And if I'm only doing one, then it beats the S&P 500 by a significant margin. Here are the problems with that, though. So the first problem, if you look at this, why is it having trouble zooming in? So you want a Sharpe ratio above 1. This is just kind of a general rule for the stock market. If your Sharpe ratio is below 1, it's not really a strategy that you want to trade. And ideally, it should be substantially above 1. And so if you look at this here, this is a plot of the number of positions. So just what I was showing here. And this shows the same thing, that the model is more successful. You can see the Sharpe ratio is rising, the fewer stocks that I'm picking. And so this is the first indication that this is a fragile model, is that the only version that got a Sharpe ratio above 1 was if I was picking one stock per day, the lowest volatility stock. I tried thresholding the model, and so I found that I couldn't really increase the performance if I increased the threshold. I was starting with a threshold of 50%. If I increased it to 51% or 52%, this didn't really improve performance. 53% saw a substantial improvement in performance, you can see here, and 54% gave a really high Sharpe ratio, but then if I increased it to 55%, it wasn't making any picks. And so 54% is almost at the edge. It's in the tail of the distribution. And so for this reason, and also the fact that it was only picking one stock per day, I concluded this is a really fragile model and not what I want to use. I want something that's a lot more robust. And so rather than looking at different portfolio strategies to improve on the results for this model, I think that the core problem was fundamental in the model, and really I needed a better model before I could look at different portfolio strategies. And so what that meant was rapidly iterating through all sorts of different features and targets to find things that were successful. Now, this is where I was at the end of January, like I said. And so the February, I wanted to rapidly iterate on the model. The problem was the code base was a huge mess, so I really had to spend all of February cleaning up the code base and making it concise. So originally, I had to write a new script every time I wanted to change how the universe is defined, change how the model works, and change the portfolio strategy. So that meant dozens of files. It was going to quickly blow up to hundreds of files by the time I finished the analysis, and it wasn't going to be usable for me or anyone else, which invalidates the second goal and makes my first goal a lot harder to do. So I spent February cleaning up the model. I already had data. I added some classes for filters. And I fed that into a class for the stock universe, which makes the stock universe really flexible and easy to define. If I decide in the future there's any more filters I want, I don't need to make a whole new script. All I have to do is add a new class. Then I made a class for the model, and I fed in the classes of features and targets for this. So this is what really took the bulk of the time. And I didn't want to have to go through and be adding a lot of features and targets after the fact. So I got a list of every single feature that I could possibly want and target that I could possibly want, only for the price data. So I hadn't incorporated fundamental data into the model yet. And so once I did this, I explored the model. These slides are all just adding the features and making sure that they work. Um, Once I started exploring the model, the first thing to do was just add every feature to the model and see how it performs. And it actually was performing worse on directional accuracy. So we went from 51.5% to 50.8%. And so that was doing worse. I looked through a lot of things to see how can I improve the model. The first most interesting thing I found was that the further I'm looking out into the future, the better it performs. So if I'm trying to predict the 5-day returns rather than the daily returns, it performs a lot better. And if I try to predict 10-day returns, it performs even better than 5-day returns, so on and so forth. So this is kind of a rule of stock market models I've found out, is that the further you're looking into the future, the better your model performs. And so that was my first really good finding. I also decided that I needed to not look at the directional accuracy because there are some stocks that are just going to go down. The directional accuracy doesn't matter so much. What matters more is these metrics. And so ignore the first two. What really matters is the information coefficient, which I call IC here, the standard deviation of the information coefficient. So the information coefficient is going to tell you basically how good your returns are going to be if you're using this model. The standard deviation of the information coefficient, the ratio of the information coefficient to information, and the t statistic. And these last three parameters tell you how stable your model is. So if you're getting a really high information coefficient, but your standard deviation's huge, and your information coefficient to information ratio is really small, then you know that you've kind of just hit a fluke and your model actually isn't very robust. And so I was looking at all sorts of ways to improve the model, and I happened upon a really good model. And so this is trying to predict 5-day future returns. Real quick point I should make on what I said earlier, which is that the model is performing better the further you look out into the future for your target. The reason for that is because if you're trying to pick daily returns, you're missing out on all the price action that happens after the market closes, the after hours where big institutions are allowed to trade, and the pre-market trading, where again big institutions are allowed to trade, but retail traders like me and you are not allowed to trade. And so you're missing out on all of that price action. If you're doing 5-day future returns, you get all of that price action into your model. And so this is the first really good model. Like I said, I have two really good models that I found. So this is the first one. I found another model that's really good, which is the same exact thing. Just a sec, let me exit out of some of my terminal tabs. Terminate. Yeah, so like I said, so this is trying to predict 5-day future returns. So I did the same model, but instead of doing 5 days into the future, I did 20 days into the future. And once again, you can see that this outperforms the 5-day model. The 5-day model was this assessment, this model was the first time I was able to get above the threshold I'm looking for on every metric. So if you look here, the information coefficient, I'm going out of these outputs should be over 0.01. Here I'm getting 0.0229. The standard deviation of the information coefficient is actually larger, and here I'm saying it should be smaller, but I'll get to that in a sec. I'll get to why that isn't a problem in a second. The ratio of information coefficient to information is 0.22, so here I wanted 0.019. On an annual basis, it's 1.58. I want it above 0.3, and the t statistic is 2.3, and I want it above 1.96. So it's hitting every metric. You might think that standard deviation isn't good, but I found this paper here which showed for successful models which have been published in papers, they get the information coefficient and the standard deviation of the information coefficient, and it's always larger by 3 to 13 times. And so that means that this is right in that range. It's at the lower end of the range. This is about 4 times as high the standard deviation is compared to the information coefficient. So this is my first really good model. Today I'm trying to incorporate treasury data. Oh, real quick, I tried removing features from this model, correlated features, and I've been going over this in the last several streams, so watch those if you're interested in how this works. But basically, the point is that removing features which were correlated did not improve the model at all. And here, actually, I tried to remove every correlated feature one by one, and none of these improved the model. Two of them, removing the log ATR and removing the stochastic oscillator, did improve the information coefficient, but it made every other metric worse. So if you remember what that means that the model's getting better returns, but we're sacrificing stability to squeeze out those returns. And so that's not something you want to do. You want a more stable model and a better model, a model which gives higher returns. And that means that you have a better model. And so I tried 3 different methods of reducing the features. None of these were successful. All of these returned worse performance. I tried lots of different things. So this is my to-dos for improving the model. I was trying to add fundamental data, and then I realized that I only have fundamental data which goes back to 2023. And so since my price data goes back to 2011, I would have to cut out 12 years of the training data. And my intuition is that's going to make the model worse, so I'm going to leave that out for now and not focus on that. And I'm going to need to find a way to get the fundamental data. So one way I could do that is the SEC Edgar database. So speaking of that, another thing I wanted to get was sector information to feed into the model. Yesterday I wrote this script to get sector information from the SEC Edgar database. But you see here when I'm writing this line to get the number of sectors which are unknown, it's 5,700 almost. And there's only 12,000 account symbols in here. So this is giving an unknown sector for about half of my tickers. And so I don't think this is going to improve things. However, I am going to go through and just look at how does the model perform if I add this. And then the other thing to add is interest rates and credit spreads. And that's what I was working on yesterday when I ended my stream. So I'm going to finish that today and see if that improves the model. And I'm also going to add this the volatility index. So once I have the volatility index and the interest rates and credit spreads, I want to see, do those improve the model? If they do, great. If they don't, that's fine because the model's already hitting all the metrics that I want. Finally, I'm going to check to see if the sector information improves the model, but I really don't think it's going to. So before I do that, like I said, I can't just add it to the model. I need to write code to add the features inside of the feature code, which is going to make the model diverse and usable not only for me, but for anyone else. And then once I finish that stuff, if they improve the model, I'm going to incorporate those to the model. If none of this improves the model, then I'm just going to go ahead with the successful model that I found right here. So this is the 5-day returns and also the successful model that I found yesterday. So if you look at these metrics, this is outperforming the 5-day return model. If I look at the decile analysis, this looks good. It's like a staircase distribution, although it's clearly not normal. It's skewed. And so I kind of have to look at that. But so I'm going to add these 2 models, the 20-day model and the 5-day model, into a paper trading setup. And then I'm going to start paper trading those. So I'm hoping I could get that code written today. Basically, I need to automate pulling the stock data and then generating the picks from the model. Oh, and before I do that even, I'm going to have to look at some portfolio strategies. But what? So all that to say, that's basically what I'm working on. Hopefully I'll finish all of that today. If I don't, I'll get around to it tomorrow because like I said, I stream every day. So speaking of, please subscribe and let's get started. So just a sec, let me put a comment in the chat to say please subscribe, and I work on this every day. Okay, let me add that. Hey, you've Mittal. How are you? You got to go back to work. Well, good luck. What time is it where you are, or are you a late night worker like me on this project? But the progress is going really good. I don't know if you. I was just blabbing there for. Oh man, that was almost 20 minutes. So I kind of got to cut down on the intro, but yeah, this is going really good. I'm really happy with the progress. And hey, Sir Night Night. Um, yeah. So let me document this real quick. So let's say model 12 using I think it was a 20-day target. But let's make sure here. So model 12. And the target was, yeah, 20 days in the future. Model 12 using a 20-day forward target. And here's the performance. And we can say outperforms 5-day target on every metric, which is really good. Okay, so now I'm gonna. So yesterday I was incorporating the new features into Feature Engine, but I didn't quite finish. So let me give this to the AI and see what it says. Okay, I'm working on incorporating interest rate features into my model, but have not completed the logic. How can I finish this up? So let's add the file. And I'm gonna listen to some music. All right, so we're at 22 minutes. My goal is by the time 1 hour's up, have these done. By the time 2 hours is up, or I'll just go by the time. So it's currently 9:47. I'm gonna say by 10:30 I want to finish these treasury features. By 11:30 I want to. So let's say. Let me write that down. So 10. Oh, no, this marker sucks. 10:40. Finish treasury features. And then by 11:30, I want to finish volatility index features. And by midnight, I want to finish tests. Midnight, I could say I want to finish sector features. And by 12, half past midnight, I want to finish tests for everything. Okay, there are my goals. So I'm gonna put some music in and get down to business. What should I listen to, Sir Night Night? I'm assuming you're the one viewer. Not jazz, though. That's the one thing I don't like. Anything but jazz. How you get so much favor on your side? Okay. Thing you want to be. To finish incorporating, we need to bridge the gap. Oh. So do I want to add a different class, or should it be a subclass of feature request? No, I don't think so. Isolate rate requests from standard features. Okay, so God, since '05. He supplied. The IRS want they 50 plus a tithe. Okay, and then we have calendar requests and other requests, so we're good. This is at a charge. Oh, nice. You like Tupac? I forgot. Did we talk about that? I love Tupac. What's your favorite Tupac song? And what's your favorite Tupac album? My favorite album is probably All Eyes on Me. But another really good album is his last album. What is it? Machiavelli, The 7-Day Theory. That one has tons of hits, and people don't talk about that as though it's a classic. It's just me against the world, baby. Wow, Me Against the World isn't one of the top songs? That's a surprise. Let you know that. Let me pull it up. And actually, this album is a good album. Alright, so we have calendar requests, other requests. Okay, so that's the same as before, so we're good. What was step 1? Rate butterfly. Okay, and these are only going to be features and not targets, so, is it... Yeah, it's changing the whole thing. So then I need to add underscore F. All columns contain underscore F by default. Since rates, why would I want to predict rates? Can only be, I'm not going to buy a house or something. And not targets. Maybe I could, that would be an interesting thing if I made a model to predict rates and I guess made a website. Rate predictions. Home buyers would like that. But it's not that interesting. Kind of everybody knows if the rates are going to go down or up before they do, right? Okay, so rate spread. So I'll add it here. Or I forget. Suffix. So where's type suffix referenced? Yeah. So underscore F goes at the end. So I guess I'll take that out. I'll do the same thing. World, baby. Okay. So I did that. Did that. 3, add phase 1.5 right after phase 1 beta merge block and right before phase 2 begins, insert a dedicated calculation block for rate features. Okay. So where should that go? After 1 but before 2. Okay. Now write a test which demonstrates how the rate features work. Which demonstrates that the rate features work. Rate features work. Use my code and not some example. I have the OHLCV data. Am I pulling the rate data? Yeah, so that's not happening in rate feature request. What did I call that data? So here's data. VIX, no. Oh, treasury rates.csv. So okay, let's search for that. Tupac's what I used to listen to in high school. Tupac was like my first. I got into Eminem, then I got into Lil Wayne, then I got into Tupac. What are some other good Tupac songs? I really like the, what's that song from the Above the Rim soundtrack? Pain! My pain, it runs deep. Share it with me. Okay, now write a test which demonstrates that the rate features work. Okay, so if beta requests, so phase 1.5 macro rate calculations. Okay, so first I have to say adjust the code so that it term 1, term 2, so that it currently the code does not include the rate data. I have this stored in // data slash no data slash dot slash data slash use it at rough life. Treasury rates. How can I incorporate this into feature engine? So that it is efficient. I only want to read this once and delete once the rate features have been calculated. An example of how the data looks is below. Make your code consistent with the data structure and the functions which calculate rate features. I should be confident that everything works as intended. Clock, clock, planet, if they press me, bust. Drinking Hennessy and getting high on the lookout for my enemies. Don't want to die, tell me why, because the stress is getting major. So term 1, term 2, that should just pass in the data. Oh. Alright, let's... Alright, let's stop this. Let's put that in again. And let's get the data. So what's the data look like? Steady mugging me. I'll be living this life. I know you feel me. It's so much pain. Quick look. Tired in the strain and the pain. They never take me alive. I'm getting high with my 4-5 cocked on these suckers. Time to die. Then they play a bunch of not Tupac songs. Alright, go to album. Alright, here's the complete and efficient implementation. Crazy. Crazy. Time goes by, puffing on light, hoping that it gets me high. Crazy, crazy. I'll just leave that part out. I'll just say, is this happening? 1671. Time goes by, puffing on lie, hoping that it gets me high. Got a nigga going crazy. Filters dates down to a unique list before applying the math. It only computes exactly what you need. Okay, so now this is kind of the process. So I make a new feature, and then I want to write a test for the feature so that I can be certain that it works. Now, if this test works, I can just go ahead and add the rates to the model and see, does that improve model performance. So real quick, let me switch the model back to the 5-day returns. Okay, now let's go to tests. New feature test. Oh, test features. If test rate features is equal to true, do this guy. And then we can say we're already importing everything from fundamental engine. So let's pass in the data though. Look, pd.read feather. Okay, then we'll say, do that, then we'll say sample price df is equal to df where df dot account symbol is equal to Apple. Okay, now let's see how does that test work. Oh, don't want to do Model Explorer. Let's get out of here. Let's go to tests. And then let's do Python 3. Now let's make sure that this is testing. So back at the top, we can say test rate features is equal to 1. And then just to make sure everything else is turned off, so turn this guy off. Okay, good. All right, so now let's run it, test features. And let's see what it outputs. So what should we see? Oh, no, I don't want fucking... God. Zoom asks me to update constantly. So it named it wrong. Probably I just passed. Fundamental engine. Oh, no, feature engine. All right, let's see how this does. Oh, import GC. What is GC? So where was that? So get handle, make engine, test features. Oh, raw rates. So in test features, okay, and here's the plot. Okay, so those are the raw rates. The 10-year minus the 2-year rate. So let's see. 10-year minus 2-year is positive until here it goes close to 0. Goes back to positive again. Let's zoom in on this region. So yeah, it gets close to 0, but it doesn't get to 0. And the lowest point is here, yeah, right here. Then it goes back up. That looks good. Butterfly. So what is a rate butterfly? Oh, this will just tell us. It's a market neutral option strategy with limited risk. By the way, if you just joined, all this, I work on this every single day. I'm slowly building up my model. My goals are not only to beat the S&P by a significant margin, but it's also to make a model that anyone can use. And so that is here, GitHub. So it's here. So the link to this is in the description. So you can go download this, try it out for yourself, or clone the repository. It also helps me out a lot if you star it, watch it, and follow me on GitHub. Also subscribe if you're interested in this project. Rate butterfly is a metric that measures the curvature or hump of the yield curve. So does it talk about this here? What to look for? Plot 1 versus plot 3. Curvature of the yield curve, it is calculated as long plus short minus 2 times mid. If the 2-year yield is perfectly halfway between the 3-month and 10-year, the yield curve is perfectly straight and the butterfly will be at 0. So curvature. So if the 2-year yield is perfectly halfway between the 3-month and 10-year, the yield curve is perfectly straight. So it should go to close to 0 somewhere around here, right? Oh no, 3. So what is it? If the 2-year, yeah, is right between. So this, it should be close to 0. Yeah, it's floating around close to 0 there. All right, finally the velocity. Look for a sharp, sudden upward spike in the 10-year line. So where do we get a good spike? Maybe here. There was a spike in 2022. Let's go to 2022. So the problem with this is since it's recent, it's going to overweight that. Here we get a nice spike. Yeah, so this looks good. So let's put this in here. So let's say today is the 17th. Happy St. Patty's Day. 3/17/2026. Added, I'll just say here, added treasury rate features. All right, let's play another song. All right, so the next step is do interest rates as a feature improve the data set. Adding to model 12. This, I'll just put a little note in the corner actually. So here's the question I'm answering. Let's put a text box in. I guess I should put that below. I need to know now. Know now. Adding to the model in model 12. This is in model 13. Need to know now. Okay, so we want to do a few different things. So first of all, let's make this pop. So we'll make a solid line, solid fill. Let's make it lime or this nice mint color. So first thing I'm going to do is add all features. Then add spread only. Add curvature only. Okay, so all spread only. Then we have butterfly only. Can you love me again? Where do I put this? Okay, so all spread only, butterfly only, velocity only. Okay, then let's put text boxes. All is the first one. Let's just center it. Okay, copy that. And let's paste it on over here. So here we're going to put in spread only. Can you love me again? Butterfly only. And let me just make sure the names are consistent. So feature engine. Oh, I got too much crap open. Get rid of that. Don't save. Yeah, don't save this crap. Where the hell's feature engine? I'll just click on it over here. So the names. You count then. All right, so spread, butterfly, velocity. All right, so here's velocity only. Okay, get out of there because we verified it. So, oh good, and I forgot about that test. So all assertions passed, no unexpected missing values found. All right, so now we can add this to the model. So model explorer. So what time is it? My goal was to finish treasury features by 10:40. We're 15 minutes ahead of schedule. Cool. Okay, so this isn't model 13. This is model 14. Model 13 was looking at the different ways of dropping out the features. So model 12, here we go, model 12. Oh yeah, here we go. All right, test model 14. If test model 14 is equal to true, let's do the same thing as model 12. And then we're going to say add dinner with Jay-Z. That's random. But yeah, of course I would pick dinner with Jay-Z over $1 million. Jay-Z, he's a genius. He knows everything. That's like the biggest moron test ever. That's like the, yeah. It really is. It's like morons think Jay-Z's really smart. They're like, he knows how to invest his money. He's a businessman. What would you learn from dinner with Jay-Z? That distracted me. Okay, so now we want to add treasury rate features. All right, so feature test, test features. And let's put that over here. Yeah, I'm happy you agree. I'm happy that wasn't a serious comment. Hey, we have 7 live viewers, so For the new people who've just joined, please subscribe. I work on this every day. Also, you could check out the GitHub for this project in the description, and you could get all the code that I'm using to run this model, to run the your own models. I haven't included the models I have in here, because I want to keep them to myself so I don't lose an edge. But you could get you can have all the code you could access all the code like I'm using here, like just defining features and feeding them into the model. You can do that yourself. So go to the GitHub. If you use it, please star it, watch it, follow me on GitHub. Okay, so now let's add those to the features. Are you going to bed? Nighty night.
Having trouble staying awake.
Oh, that's not good.
Dad went out to do exercises.
Okay, see you tomorrow.
Hey, sweet dreams. Have a good night. Don't stay up all night.
Okay, I'll try my best.
Love you.
Love you too. All right. So let's add those to the features. Instead of, I'll call these rate features. Okay, so this looks good. If test model 13, no, yeah, test model 14. So let's add that up here and turn it on. So take off model 12, which I had. Test model 14, and I forgot what the target is. So I want to do a 5-day future target. Yep, good to go. Make sure it's saved. Now we can run it. Okay, so now we could go to Explorers. So this Explorers folder I haven't included in the repository, but everything else is in there other than some random crap. So Python 3, Model Explorer. Alright, so this is what I'm testing. Okay, so I guess I'm going to wait to see if this improves the model. If it does improve the model, I'm going to try some transformations. I guess even if it doesn't improve the model, I want to test how transformations work. So does CSZ transformation improve model 14? Okay, and then so let's go up. I've incorporated rate features. So that's good to go. I also have data for the volatility index in, so where's that? Data slash VIX CLS2. I just want, where's the first one? Where is that? I don't see VIX CLS. What? Oh, it's right here. In slash data slash VIX CLS.CSV. Use this to incorporate a VIX feature. It should just add a feature column which gives the VIX price. Uh-oh. How am I calling the features? I guess we'll see. If it's not calling the features, it'll give the same output as model 12 with a 5-day future target. So model 12 is this. So let's just make this smaller. Oops. Then I could add notes at the bottom. Oh, this. I don't want there, I want it here. And here I'll say, copy this. Okay, we're at trial 42. It's doing 50 trials, so it should be done in a sec. Okay, so here's how the features did. It's kind of hard to tell what's what. So where did it fall? Are there rate features in here? I don't see any rate features, so... But the information coefficient's better. Standard deviation's about the same, I think. Let me zoom in on this, we could compare easily. Alright, so information coefficient's better. Standard deviation is slightly worse. You know, that's kind of insignificant. ICIR 0.22, so slightly better. Annualized, slightly better. T-statistic, slightly better. Yeah, but the problem is I don't know what it's doing. So let's add the debugger here. I mean, print model features. So then I could just say for feature. So where's the model getting the features? I'm pretty sure it's just getting everything with an F. So clean analysis is the model. And then when I'm doing get universe for month, add filters. Oh, this is universe. This is model. So add target, add features, has features inside of split data. Self.features is key for key and self.data.keys if f in key dot split on underscore. So then we'll say feature for feature in model dot features. For feature in model.features, print, build a black box and sell your house and dump every penny into it. Well, I wish I had a house to sell, but that's not going to work. But what the hell's a black box? You mean a black box model? Why would I want a black box model? Oh, you're kidding. You're full of jokes. Okay. That took me a sec. I got it. I don't know why the features aren't in here, though. So stoke, upper. Okay. Oh, did it run 2 models? It won't let me exit out of this. Is this an error? So for each feature, we want to say print, and then in feature requests, we have self.name, rate feature request. We also have self.name. So let's just print feature.name. And then I'll know that it's being passed into the model as features. And then if there's anything else I want to do, I could just put in the debugger right there. Okay, so now it's running again. And model evaluate. Yeah, so it should be giving me the quantile spread too. Okay, so I also want to add in the sector information that I got. Yeah, I know that. Well, yeah, you have the intuition for that. The regime feature does seem to be the most important. So maybe something to work on in the future is making my own regime feature or getting better regime features. But yeah, you're right. The regime feature seems to be the most important. You're right as always, Sir Night Night. Okay. I guess let me delete this and I'll just paste this slide in. And all I gotta do is get. Oh no, I don't. Okay, so I'll just do the same thing here. Make that shorter. Make this guy shorter. Make this guy shorter. And then let's add in this. Okay, now I'm going to add in the sector data as a feature. Oh no, I forgot I was in the middle of adding volatility index as a feature. Here is the volatility. Here's the VIX. Here is a sample of the VIX data. Reassess whether your answer and suggested code is correct. Okay, so let's get a sample of that data. So if you just tuned in, I'd work on this every day. Please subscribe. You could check out the repository where you can do the same analysis that I'm doing. You could get all the code that I'm using. Download it, star it, watch it, and follow me on GitHub. That helps me out a lot. So where's this guy at? We're at trial 20, so not halfway done with the trials yet. So let's see. Thank you, blah, 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 blah. Here's the corrected exact implementation. Okay. So let's add it to the feature registry. Oh no, this is Model Explorer. We want feature engine. So here are all the features. Let's add it. Add this guy. Ooh, do I really want a VIX feature request? Why do you add the VIX feature request as its own feature? Why can't it be treated the same as other price features? So I don't think I want to do that. Okay, this guy's at 45, 46. So we're going to get the same output as before, but then I'll also be able to print everything to make sure that it's giving the same out, or to make sure that it's adding those as features. So it did show an improvement, but I want to make sure that it's actually adding the features. You could treat VIX as a standard price feature, but doing so would cause performance bottlenecks. Okay, so here are the features again. And I still don't see the rate features. Oh my god, are you kidding me? The same fucking error. Okay. So I guess I won't make that full screen. I forgot that's what I did last time that messed that up. Is there weekend data for the VIX data set? One, two, three, 4, 5. There's no 6 or 7, 8, 9, 10, 11, 12, 13, 14. Yeah. I don't have weekend data in the VIX data set. It should include every date in my price data. Why can't this happen in its own function, similar to how the forward log return works? Similar to how forward log return works? Question mark. Yeah, so I don't know why that wouldn't work. This guy's still going through tuning params. All right, so it has to do 50 tuning iterations. Yeah, so why can't I just add the VIX as it is? That's the big question. Okay, there you go, dopey. Okay. Update the request sorting in phase 1. Okay, so we need to add the macro requests. better off alone? Do you think you're better off alone? Alright, 1.5, but before 2. So I'll call this 1.2. And let's call this 1.1. Okay. Write a test for the VIX data. Okay, well, before that, I mean, it's just adding in the price data, so it's not going to be that interesting to look at. For the VIX data feature, do I want to put in the raw prices from the data set or something else? Alright, 45, so this guy's almost done. We'll run this, and then we'll do the next test, and then we'll go from there. Okay, I'm just going to click right out of the feature importance plot, because that's not showing, that's just going to fuck this up. So, come on. Alright, here's feature importance. Let's get rid of this guy. Get rid of this guy. Here's the result. The information coefficient's now worse. Standard deviation's worse. Ratio's worse. T-statistic is worse. Why was it just better? Yo, really? So I still need to make sure that every feature's in here. So, well, I'm just not thinking, print feature. But it's not doing the, oh, because it was failing before I got to the debugger. So let's do this one more time. I think I've corrected everything. So let's make sure it works. Okay, so this is running. I'm gonna look at this next, but real quick, I'm gonna grab a beer, and that's gonna help me pound through the rest of this. I need to stop drinking beers during these streams, but it kind of helps me focus. So I'll be right back. All right, now let's read this. So, one of the most important questions you can ask. VIX of 20 means different things. at different times. So in column times 20 is a big problem, yeah. VIX velocity. Rolling VIX z-score. This tells the model how high is the VIX compared to the last month. Okay. Do I care about the VIX velocity? Yeah, I guess I could just add those. Do I want to do that though? No. Write logic which I can incorporate into feature engine. I'll say, is it possible to? Is it possible to write logic which I can incorporate directly into feature engine which calculates all of these individually so that I can only get the ones which I specify. Get the features which I specify. Do you think you're better off alone? Do you think you're better off alone? This is a cool song. Explain what's going down. Okay, exit out of that guy. Here's the results. I'll just screenshot it to paste in, but I still have a hunch that this isn't working. You can fly. So the information coefficient's pretty unsteady here. All this stuff's pretty unsteady. You know, does model 12 return something different every time? It was looking out of place. Cigarette. Alright, so these features are 17. So sweet. Okay, so let's look at feature test. And how am I doing it here? So, goodbye all night. Looking for the answers. So feature engine works on those. Did I not save this? Oh, it's saved. Alright, let's switch over to my other user. So we want to give it feature engine and clean analysis. What's cool? Cookies? What do you mean it's cool? Sounds like you're saying it's cool. Don't worry about it. It's cool. Alright, so why are the rate features not being incorporated? Oh, really? The calendar features are missing too. Oh, I forgot to change it. Yeah, so I updated this without adding the F at the end. Okay, so I just want to add those. Okay, now this should work. I would have seen that if I'd looked at the model data. The song you were asking if it was cool or not. What song? I forgot. Did I say that? Oh no, I just said it was a cool song, didn't I? Do you guys like Daft Punk? This is a cool song. Do 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 do. Do 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 do. Do 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 do. Okay, let's see. So this will be nice because it's easy to add. Do calendar features improve model 12. So let's add a note. Does sector feature improve model 12? So it seems like model 12 has a fair bit of variance to it, so that's going to be something I need to look at as well. So I'll just give it the same request I gave it earlier before it made me switch users. What is the best practice used by quants? Hey, did you see Sir Night Night? Did you see that they were talking about removing quarterly report requirements? The SEC was. It's kind of interesting and odd, and probably a recession indicator. I think. Let's get rid of this guy. Because it doesn't happen every day. So I chained myself to a friend. Come on. .022. So that's slightly worse, I think. Yep. Mean rank IC is worse. I'll just put it in. So here's every feature now. Here we go, rates. So the 10-year to 2-year rate spread was important. Rate butterfly was important, but it's making the model worse. What about ICIR? So 0.1751. And, oh, so 0.17. Okay, so that's worse. Annualized is worse. T-statistic is worse. You're such a special. You're so fucking special. But I'm a creep. Yeah, I'm a weirdo. Hell am I doing here? I don't belong here. I don't care if it hurts. Don't jump and troll. I want a perfect body. I want a perfect soul. I want you to notice when I'm not around. I'm real fucking special. But I'm a creep. I'm a weirdo. Alright, so what if we only include spread? Oh no, I want to... No, not that. Spread. So I'm kind of confused on why the model... So if the model's getting worse with these features, why would it... Why would those features... You would think if it's getting worse with those features would be at the bottom, the least important. But at least the spread is really high. The other two are fairly high. And when I'm back in Chicago, I feel it. I was in it. Where's this guy? Oh, it's only on trial 5. So then I need to see. This actually doesn't apply. Goodbye. Suggest some songs. Alright, trial 39. So I'm gonna add this. I have sector features. I'll hold off on highlighting that. So what are bearer risk factors again? And you'll begin to wonder why you came. So that seems like it's going to be redundant. Okay, here are the features. So the rate spread is the second most important feature. That makes sense because it's also a regime feature. Here's how. So that looks worse. It's definitely worse. Hey, buddy. Oh, yeah, and that's much worse. So that's weird. It calculated it as the second most important metric. When I add interest rate spread to my model, the interest rate spread is the second most important feature. However, the model performs worse than it does when I don't include this feature. What is the cause of this? My back is itchy because I got sunburnt this weekend. Oh yeah, we're past 11 o'clock. Okay. Okay, so this is good. It's not that the stuff's not improving my model, it's that I'm using it wrong. Okay, so I'm going to insert that here. Let's put a note. So calendar features are also macro, so no. Okay, so the sector data I don't think is going to work for now. Let me go back to my to-dos. So sector data isn't going to work because I only have 50%. Not worrying about the assessment class. Model save, that'll be easy. Macro features I don't want. Finally, I could add a transform. I don't know, the cross-sectional transform's working pretty well. Okay, so I'm going to go ahead with these models. Is there anything else I can do to make them better? So this I don't care because my transform's working really well. Macro features, not worth adding to this model. Make model save work. Add assessment class, don't care about that. Add sector information. Okay, so we want the model save to work. First, I'm going to test what's the distribution of the stuff on model 12. So let's turn model 12 back on. Turn this guy off. And let's just add the model save into here and see why is it not working. So test features, new feature test, clean analysis, tune params, generate targets and features, train model, test model, calculate metrics, quantile spread, reduction. So where's save? So we're going to save it in /data/models. /model 12 5-day. Alright, so model 12, let's make sure it's on. Yep. Okay, now let's run this. Now let's think. When we're doing the portfolio test, what do we want to do? I have a model with Okay, so if we're looking at the variance of the results, let's add this stuff back in. Sector information. I wasn't getting information on enough stocks. I'm afraid of having survivorship bias. Don't care about that. Okay. So we have 5 viewers. If you're new, please subscribe. Go to the GitHub. The link's in the description. Star the GitHub. Follow me on the GitHub, and watch the GitHub repository. All those things really help me out a lot. Also join the Discord. I want to get an interesting community of people going to discuss interesting stuff. And also thanks for watching, of course. And happy St. Patrick's Day. If it's still the 17th where you are, it is where I am. Okay, trial 43 finished, so we're close to done. I want to see what's the variance of this model. And if we're getting low variance on the features, let's go ahead. If I'm getting high variance on the features, it looks like we just randomly happened upon something that performed well and the model isn't robust, which would be a really big disappointment at this stage. I've thought for almost a week now that I have a really good model going, so let's see what happens. It's about to finish. Okay, so here's the importance of all the features. Oh. Damn it. So the problem is in... Well, we could look at this. So, ooh, uh-oh. Uh-oh. This is performing worse. Did I change something? I don't like that. Rank IC is worse. Standard deviation's worse. Information coefficient to information is worse. T statistics worse. Ooh, that's not good. So the save is not working because when I'm doing train model, yeah, don't do that. Just do save name.txt. Let's go back to model 12. Good. That'll work. Okay, let's run it again. Wait, what's fantastic data? Thanks, by the way, but just the data set or yeah, what's good data? I've been thinking I don't feel like the data set's that great. I feel like the data set's just standard. So it seems like standard price data to me. It'd be cool if I could get the sector information, but I'm not getting that. But I could try a different training target and see how that works. But I'm worried. Oh yeah, so I'm worried this is performing worse. So let me look at the GitHub and see. I wish I'd put the date that I did this. Do I have a date? So 310. So that was what, last Tuesday? So I'm gonna look for all changes on the GitHub in the last week. Yeah, I want to see if there's any changes to the model itself. So history, added shadow feature reductions, that won't be it. Added method to remove correlated features. Added more robust metrics. Model 12 has the more robust metrics. So it should be after this. Changed back to Huber. Still that, right? Objective is Huber. Metric is Huber. Yeah. So it's still that. So robust metrics for multi-day forward return targets. Let's see if I change something in here. I did. Damn. That sucks. So I gotta take that shit out. Now I'm passing in the seed. That hasn't changed. So it should give me the same performance now. I can't believe that crap. Am I gonna have to reassess everything? $20 minutes left in the day. Okay, but the good thing is I think I found what the problem was that I changed. I can't believe I did that. Call sample by tree. Let's go back, see if we changed anything else. Oh no, that was the one I just checked. Yep, nothing else has changed. And the seed is the same, so I should really be getting the same metric, the same result. So what do I want to reassess? Oh, this just sucks. So let's do 317. Hey, Victor. I have two end goals. I put them, let me type 2026. Two end goals with this. Number one, beat the S&P 500 by a significant margin in all regimes. Number two, so I'm doing this in Python. I want to use my code, generalize it, and make it really flexible. And the idea is this will make a usable tool that anyone can use. So I'm not sharing my models, but I'm sharing the code I'm using to make the models. And it's pretty simple. You could see here, you basically just have to define the features you want. I've added every possible price feature or target that you could want. So if you only have price data, you have all of these. I've added all sorts of other data, but the price data is what's working really well. So you just add them in once you have all of your features. So that's really what you have to write. It's not even hard to write. You could just have ChatGPT or use whatever chat model you like to read the code base, and you could just define the features, say what features you want, define the target you want, and then this is all you have to do. You define a universe of data. So I have a class for that. Then you make the model, feed the universe data into the model, feed the features into the model, feed the target into the model, define how to split the data, ignore that. Then you just train the model and then evaluate it. So, 5 lines of Python. What is this? 1, 2, 3, 4, 5, 6, 7. So, define the features you want. Then you just need 7 lines of Python code and you could run a model for yourself. And that makes it so you can rapidly iterate, try all sorts of different things, and get a really good model going. So if you're interested in that, you could go to the GitHub, which is in the description. Download it for yourself. I'd appreciate feedback on what you think about it, if you find it useful. If you don't find it useful, what things can I change to make it useful? So I got this really good model. Right here, it's hitting every metric that I want. But then, without thinking, I made some changes to this when I was trying to do this remove correlated features. And I made a change which changed how the model's working, and it degraded the performance on this. So that actually means I'm gonna have to go through all of this exploration that I did and see, are these values that I got? I found that I'm not able to improve the model at all if I trim features. And so the question I have now is that true? Or is it the case that that change that I made degraded all the features, and some of them, which I think performed worse when I removed them, made the model perform worse when I removed them? Maybe it could be the case that it's actually making the model perform better. Specifically, I'm interested in this log ATR and stochastic oscillator. When I removed those, I was able to increase the information coefficient, but I made every other metric that I'm looking at worse, which means I'm sacrificing stability for returns, which is not something you want to do really when you're making a model. And so now I'm going to have to dig into that and see, maybe this is actually kind of hopeful because maybe I am able to improve the model more. It's also a bummer though because I thought I was gonna, get to the point of automating the model for paper trading tonight, and it doesn't seem like I'm gonna get there because I need to go through and do so much more analysis. I basically need to repeat my analysis that I've done over the last like 4 or 5 days ago or so. Not repeat the whole thing, but lots of things I'm gonna have to repeat. So that kind of sucks. But it's not so bad. I also did. If I remember, maybe I could go back and watch my stream to see when I changed it. But I'm pretty sure that any of the automated feature dropping buttons, I made that change to the model to try to get some of the automated feature dropping to work better. And so I'm confident still that those don't work. I have to verify. But the real question here is if I go through and drop every feature one by one, do any of these improve the model? And now I kind of have a hunch that some of them might be improving the model if I drop them out. All right, so this is the feature importance for the model I just ran. Let's see how we do. So now look at this. We got the information coefficient up a lot higher. It's not exactly what it was. So I was getting 0.0229. Now I'm getting 222. Standard deviation's a little bit worse. Information coefficient to information's worse. And this t statistic is worse. Yeah. Well, I'm gonna have to see what else. What else could I have changed? So Model Explorer. Oh. Model 14. Model 12. So when I was going through and removing things one by one, I forgot to add in the volatility. So now, if I have this volatility here, I was commenting that out earlier. If I add it back in, do I get the same performance that the model got from before? So here you see this. That's the stable staircase pattern, but alpha is lower than it was, which is to be expected. The metrics are worse. Okay, but what's interesting about that is I was dropping out volatility. What was I getting? 0.222. So what do I get here? Oh, so it's still, I was getting higher. So assuming I could get the same performance here with all features, it would be pretty interesting to see stochastic oscillator and log ATR. Maybe that's actually improving things. So here, update. The update is that I added a change to the model hyperparameter optimization when I was trying to get the correlation drop to work. Okay, then let's show what I changed. So back to here. Let's get back out of here, and which change? It was this one. Added method for correlated features. Kuhn and Johnson. So this is the really nice thing about GitHub. If there's some error you're getting and it's because you changed something in the code, you could go back and look at your changes and see, you know, what day did this change and what was I doing when it changed. If you know, make good commit messages. I'll just add the commit to so that was on March. Oh, you know, this is only on this was from Saturday, and today's Tuesday, so it really isn't as bad as I thought. I just kind of wasted a couple days, but that's okay. I didn't totally waste a couple days. Yesterday I spent the day getting new features. Today I spent the beginning of the stream incorporating the new features. So all's not lost. It's all good. Okay. So now redo everything after Kuhn and Johnson feature, correlated feature, I'll just say feature trimming. Okay, and I have to go to the bathroom really quick, so I'll be right back. Hey, Sir Night Night. Yeah, I just feel stupid. But yeah, it definitely happens. It happened at work. I've been doing this analysis for, I guess, like the last week or so. And then today I did all this complicated math to figure this stuff out, and then today I learned we had a calibration for it, and there was no math required. And I was like, there goes fucking 2 days of figuring out that math and measuring everything and then getting the measurements. And turns out my stuff's inaccurate. We just need to use the calibration that we got. So it's part of life. Once again, right? Something hard happens. All you can do is have a good attitude about it. If you have a good attitude, you have an edge on everybody else. 0.0219. So the results are still worse. So The question is, what day did I get that? It was right after I added cross-sectional z-score. Okay, so what day did I do that? Scripts. Added rate features. Added method to remove correlated features from Kuhn and Johnson. More robust metrics for multi-day forward return targets. So I guess this was on Friday. It was really Thursday night that I did this. I changed clean analysis. Return val. Well, it's giving these values though, right? Yeah, it's giving the robust metrics. So it was after I added that. Definitely don't feel that way. I've gone through what you've gone through so many times. Even at times where I had something legit, told my wife, found the truth. Oh my god, yeah, that's the worst. If you tell your wife, or boy, I've had that with my ex-girlfriend. That happened. I was always doing that. I'd be like, oh, I found this betting model that works for Rich. Actually, like at the end of what was that? I think it was the end of 2023. I got a betting strategy that worked really well. In like a month, I turned $200 into $10,000, and then it worked well for the NFL regular season. And then the playoffs happened, and I guess it, regime change. Playoffs is a different regime from the regular season. I turned like, I forgot what it was. I think it was $350 I put in, and it went up to above $10,000. I think I hit $12,000 at the peak. You wanna? Well, I would show it. Oh yeah, I could. I mean, I don't have any money in there. I haven't really made any money, so I may as well show it. But yeah. Um, um, Yeah, here's, like I said, telling my family, here's an email to my parents. Watch me get rich. Um, whoa. Well, that was exaggerated. I thought it was, somehow in my head, I thought it was 12,000. But look, I got really good up to, this is the last week of the regular season. So, for a few weeks in December, I was on top of the world. Last week of the regular season, it went up to 2,700. And then it fell way down. During playoffs. I got killed, and it went down to like nothing. But I guess I'm up $75 all time, so great. Anyway, you can see I kind of stopped, but betting, it doesn't seem like a higher pursuit. Like I've said before, I feel like the stock market really is a higher pursuit. I think God likes it. I think God likes you allocating money to companies that are doing a good job. He doesn't want you allocating money to war companies or evil companies that are making money. But good companies that are making money from benefiting people, I think God likes that. So I should add a filter to filter out evil companies. Evil assets. No evil assets. 0.0219. So it's worse. Yeah, what the hell's different? Oh, I should have saved that model. Time period 5. Shift is 0. Am I using the same universe? Universe 1? Okay. I think universe 1. Oh! I think universe 1 is the, includes ETFs, but let me look. Oh yeah, universe 2 includes ETFs, so universe 1 has no ETFs. Okay, so that's not it. Where'd the Model Explorer go? Explorers, Model Explorer. So did I change anything in here since then? Where is it? Okay, let's go back to commits. I might have accidentally changed something. So I think it's in... Oh, Model Explorer I don't have there, so I have no way of knowing. So I'm using the right universe. Let's look at this again. So Model 12. It's including all of the features. Man, I should put in how the model, everything about the model before I change it. Might be just splitting the data differently. The results are really close. So let's go to scripts. I think I checked clean analysis, right? So did I change anything here? Nope. Changed that. Nothing down here was changed. Okay, so this was a commit, but maybe... Oh, so I did change that. But that's because return... That was being censored out. So back to clean analysis. Tune params. Return values mean absolute error. Here's what the plot looks like. This just sucks. Okay. Now, maybe this is just from variance in the model, so I'm going to run this again. And then I'm going to try dropping out those two features, log ATR and stochastic oscillator. I think there's a chance those could improve the model, so I want to see. And just to make sure, are we running model 12? Oh, it's not even there. Model Explorer. 0.7, 0.851. So, I mean, it's so close, I think it might be how I'm splitting the data. It's still hitting what I want for every metric. So I think we could just go ahead with this. It's past midnight, so St. Patty's is over. Very sad, but happy March 18th, everybody. West Coast time. Okay, so what do I want to test? It's basically, do the dropouts work? Do the other transformations work? So let's try PCA method. Say it's still St. Patty's. I did find some interesting stuff this stream. Like, I was able to incorporate the features. I realized that these macro features aren't going to use my data set because I'm getting the z-score. So and the macro features are going to be the same for every stock, and the z-score is trying to get the difference in stocks. And so instead of learning, some useful parameter, it's just going to learn what was going on that day. But the macro features will be useful for the portfolio strategy. So I think that's what I'm going to do, is I'm going to do another LGBM for the portfolio strategy, add macro features into it, and train it to get the best returns possible. Let's see, what does the chat model think about that? It's hot here. Okay. So these are basically the same small variants. I guess it's slightly better, but it's not going to get up to what the previous was. So let's try removing that feature. So first let's remove log ATR. What the hell? Oh, that's 14, okay. Model 12. ATR. Log ATR. Okay, and here are the results for that one I just ran. Whoa, but the alpha's worse. 2023 to 2020. Oh yeah, so here I can test. It's going from May 2023 to current, or January or February or whatever. Yeah, same range, better return. Yeah, I have no idea why that is. Okay, so now we're dropping out the feature, log ATR, and let's run the model again. What, buddy? We'll go out soon, I promise. It's after midnight. It's okay, buddy. You and me are gonna go out soon. I just gotta finish this. So, okay. Before I finish this stream, I want to reassess everything. Good boy. So now I've dropped out that feature. So let's add this in here. Tuning params. All right, so it's going to tune these, and then we'll get an answer. Buddy really wants to go outside. So I'm actually going to end the stream for now. Please subscribe. Go to the GitHub. The link's in the description. Star the GitHub. Watch the GitHub. Follow me on GitHub. And join the Discord. The Discord's cool because we can talk about interesting things. If you star the GitHub, watch the GitHub, and follow me on GitHub, that really helps me out. Raising my coding profile makes it easier to get coding jobs and freelance coding gigs. And then subscribing, of course, you can watch the stream regularly. And that helps me out because I want as many subscribers as possible. So that's it for tonight. I'll be working more on this tomorrow. I work on this every single day. Adios. Have a good rest of your night.